Good afternoon. Good afternoon. Hello. It seems that I'm alive. Yeah, this is something I should work on because I don't have a direct feedback. I don't have another device connected as a user, as a guest. So not guest, a visitor or viewer. So yeah, I hope we are fine now. The program for today is to redesign, I don't know if that's a correct term. I want to adapt the official 2 gig active probe by James Wilson. Thank you, James. I don't know you, I didn't find anything about you, but I like your project and I want to customize it a little. One thing is some comments I was given when I posted about your probe, about the active scope probe on LinkedIn last week or the week before. I think the week before. Yeah, there were some tips. The one major change was to replace the line between the amp and the SMA connector, to replace it with a connector as close as possible to the IC and use a coaxial wire with some small connector on one side and SMA or BNC on the other side. That can be something we can change. What's on my mind is to change the power entry. Yeah, I think something like USB Type-C can be fine. I don't know if the quality of the power entry supplied by a regular USB power delivery adapters is okay for this, but it's a connector only. It can be supplied with a custom cable connected with power supply of another type. So yeah, that is something I want to modify during this entire session, and I think the next week and maybe the week after the New Year's, I don't want to use a word improvement. I want to customize. I don't have so much RF design experience, but I want to at least create a prototype with that active probe, and if it goes well, we will have a new slightly modified design. What can be improved as well is the connection, not improved. When I stopped telling you about improvement and I don't want to use the word improve, I used it. So anyway, I want to modify the tip connection and the ground connection. I think we can inspire ourselves with 𝗶𝗶𝗫 probes. These ones are for the regular, like single-ended, single wire connection. This is something that can be considered as well, but I wanted to find this. Yeah, But this is not a scope probe, is it? Where is the ground connection of the probe? Yeah, this is clearly the ground spring, but the other one doesn't have ground connection, and ground connection is sometimes more important than... Aha, I can see those I can see that there is an extra ground connection from each probe. Okay. Anyway, yeah, something like this can be improved or changed. There are some lovely tips by 𝗞𝗖𝗍𝗍 or the SensePeak company. I received a set of spare tips, nice spring-loaded tips. So yeah, this is something we want to use as well. Yeah, the original design is pretty universal. There are only soldering tips, soldering pads, so we can check some pogo pins or yeah, similar devices. Yeah, a spring-loaded tip would be the best. Okay, so in the meantime, I downloaded, or before the show, I downloaded the project, not this one, from the GitHub. So let's check the state. Board, I think. Yeah, it's a Altium Designer project, and frankly, I don't want to use the import features of the KiCad. It can import the project from Altium, but I want to start with only a PDF of the schematic, where it is. I think in the manufacturing, yes, manufacturing schematic prints here. Yeah, here is the schematic, like 2-page schematic. Yeah, I think the power supply, the inverter, the cap mode inverter, not cap mode, I don't know how to say it. Like when the energy is flowing between the input and output capacitor. I'm dumb. Let's check the availability at least, and the name of the device. Yeah, charge pump. Yeah, charge pump is the term. I'm sorry for my brain capacity. Okay, so it means that the device is well available, and here is the LDO for the VCC. We would need a complete BOM. It should be in the manufacturing folder as well. Some caps, no problem. The standard, I think OPA 140 op amp. Yeah, looks like well available as well, but this can be an issue. Buff 802. Let's check as well. above 802. Okay, there are two versions. Oh, high-speed operation amplifiers. This is what we want. Extra low noise, €6 per piece, 1,200. And it's QFN. Yes, VQFN 16 with, I think, very reasonable 0.5 millimeter pitch. Am I right? Yes, am I right? Yes, I'm right. Okay, so this is something I want to start with. So symbols, and yeah, we will create the schematic either from scratch or at the end I will import the schematic and replace the symbols only to keep the tracks, to keep the wires, to avoid mistakes. Here is the potentiometer, and I'm checking VEE. Where is the source of VEE? VEE. Yeah, and now I'm looking for the BOM. Here is the BOM. And the LDO is U3. Yes, the spreadsheet looks different. That's correct. U3 is here. Yes, here is the part number. Let's see. What it is. And it is, aha, it's positive and negative. Okay, so it accepts, yes, positive and negative voltage. Yeah, as you can see, I didn't do my homework. Well, I don't think it's a homework thing here. I'm starting with this design, and yeah, there is unfiltered design stream, so you can see my mental process as well. So there are two, yes, in positive input and negative input. Okay, the V minus is made by this charge pump, okay, from V plus, perfect. And there are two outputs, VCC and output negative. Yeah, that looks like a nice device. Very long noise, I think. Yes, 21 micro V RMS in this band. That's slightly worse than the op-amp, but yeah, I think the noise floor will be pretty good. And as I said, I don't know if the regular USB power delivery wouldn't disturb the noise parameters. Another possibility, of course, is the battery supply. The nominal input voltage is what? Let's check the project website. Let's ask what is the power supply voltage. And in the meantime, I can see that there is a comment. Aaron Dallen, good afternoon. The gold spring is the ground. This makes the total loop path very small as opposed to the long alligator clip. Sure, sure, indeed. Indeed. And is here the probe in action? I don't think so. Probably you react to my investigation of the 𝗞𝗶𝗖𝗱 thing, I think. But thank you anyway. Yeah, you are definitely 100% correct. Thank you. Thank you, Aaron. Thank you for being here. Yeah. Which topic are going on? Yeah, I want to modify the design of the active scope probe with 2 gig bandwidth by James Wilson, and now I am in the state of making thumb of myself because I'm completely green to this design and I'm going step by step. The first step is to understand the design. So now I went through all the ICs and the result will be in 1 week or 2, 3, I don't know. The Christmas thing disturbed my my design stream streak, but I think in the first week of January definitely the design will be finished. So last thing I did was that I asked what is the power supply voltage of this probe. It seems that there is no such a info in the website, but I don't know. It was strange. VCC not found. 5 volt, 9 volt, I don't know what is the maximum input voltage of the charge pump. Maybe on the GitHub? No. Board. Manufacturing. Oh, we'll see. Yeah, there is a yeah, I can, but I can't share I can't comment during the session, so I can edit the ticker for you. But if you use your Google thing with 2 gig active probe James Wilson, you would be, I think, faster than me. Anyway, VCC. What is the maximum input voltage of the charge pump? This is something that can be limiting to the design, to the power path. Data sheet. Okay, 32 volt from 5 volt. And this limit is 33, okay. So the buff op amp limiting voltage is 6.5 plus minus, so okay. So it means that 5 volt seems like a good, or 6 volt good voltage. Okay. And I think the IP, what was the other one? OPA 140 will be plus minus 15 or something. That's a pretty normal op amp. Yeah, 18 or 36 single-ended. Yes, so 5 volt. 5 VCC or V plus is 5 volt. So yeah. So yeah, I will start step by step now. Anyway, anytime, Nazar, anytime. Thank you for being here. Yeah, so LTC 3261. Let's check the standard KiCad library. if there is something like this, low nose dual supply inverting. Yeah, this is something, but this is dual. We have only single channel. Okay, so I will create a new, I think, new thing based on the data sheet and based on the reference schematic by James Wilson. So I can close. Here is the, yeah, I didn't see it. Here is the inverter or inverting charge pump device. Yeah, what is the, okay. Yeah, I can say that the datasheet symbol is looking better than this one, but oh, anyway. Okay, split screen mode as always. Here is our symbol editor. Okay, I will create a new symbol from scratch. So symbol name will be this one. No, derived from nothing. So VIN, power input, enable. This is clear input. As you can see, I don't enter, so I'm not putting the pin number into the port properties. I will do it when the symbol is created, because this datasheet symbol doesn't contain pin numbers, but here is a table on the other, like page 2, 3, 4, 5, and I will edit all the pin numbers at once. Mode will be input as well. Can be close to enable. V out is definitely power output. Yes, RT. Probably input as well. And ground. We all love ground. Save. And C++, C-, which are entry points for the switching cap. I want to place these two ports far from each other enough that the cap symbol will fit in between them. That's the most convenient way, and for the sake of symmetry, I will push these two ports far from here. And as the original scheme said, there are 5 not connect ports and 1 ePad. So ePad will be here. And 5 and C invisible ports will be, I don't know, somewhere here. Oh, come on. Okay, so we have the rough draft of the symbol. Now we have to edit the pin numbers and make a check of the ports. Okay, here are the pin numbers. So input voltage 9, enable 10, mode 11, and C is not here, V plus, which is no V plus, C plus. There should be C plus. Yeah, I made a mistake. Yeah, C plus. Okay. Okay. C plus is 8. Ground is 13. 𝗞𝗏 is 14. No, 14. The package is 16. 12 pin MSOP. Okay, so 13 is ground. How can be ground 13 when there is 12 ports only? 13 is ground. 13 is ground, 𝗞𝗏, yes. So it means that this diagram 13. Okay. When I saw 12, why I said 12? Aha! Aha, I was mistaken by the 𝗞𝗏. Ah, I can see now. 𝗞𝗏 13. Ah, there is no ground. Okay, okay, so ground is 𝗞𝗏. Okay, so I will keep the 𝗞𝗏 only and remove the ground. V out 4, RT 12, and C will be here. First NC is 1, second is 3, third is 6, fourth is 7, and the last one is 12. Okay, so as we said, ground will be get rid of, and 13 is 𝗞𝗏 again. No issues found. Okay, but we will need to do a check again. So sorted by numbers. First is NC, RT, NC, V out, C minus, NC, NC, C plus, V in, enable mode, NC, and finally 𝗞𝗏 on the bottom. Okay, now the functions of each pin, which is important, at least I'm not sure with RT. RT is input connection, switching frequency, okay. So it's input or passive, I can say. I will set it to passive. Enable is input, okay, and mode is input, okay. That can work. Properties. So footprint is something we should start with. MSOP 12. Okay, so let's check my. Yeah, the value is obviously this. Footprint is here. MSOP 12. This is MSOP 12 with pitch 0.65, which is MSOP, and 3 times 4 is the body size. What is the body size here? 4 times 3. Yeah, this is our package, and the pitch, for just to be sure, is 0.65, as you can see here. Okay, so this is our package. Datasheet link is here. Description can be copied from here. So inverting charge pump, 45 to 32 volt in, and MSOP 12. Manufacturing order code is Here, what's the difference between? Yeah, I won't complicate things. I will take this one. Yeah, to be 100% sure, we should check the ordering section of the data sheet if there is something like this. Ordering here. So we have this one, which is tape and reel, standard temperature range, which is something we can live with, or industrial, they say I. Okay, that's good. Supplier is Mauser, and JLCP-CB code. I always add the JLCP-CB code because sometimes it's reasonable to let manufacture the device outside of my lab. I think this is our device, and here will be a charge, pump or inverter. Okay, so we have our symbol for the charge pump. Yes, what else? This power, this LDO, or yeah, that's LDO. Here is the, so we can close the datasheet of this, we can close this, we can close, what is this? Yeah, we can close this, and here's the buff, here is the OPA, and here is the, okay, so I will look for the product page on Mauser. Again, okay, perfectly available, and here is the datasheet. Okay, so it's positive and negative LDO voltage regulator. Okay, so basically low voltage, low noise LDOs in one package, and yeah, we have to create a symbol. But I think in like 5 years ago, I used a similar TPS7 family LDO in one of my designs, or a few of them. So let's try TPS. Am I right? Yes, TPS 7A. Yeah, this, look, this was this one. It was A4, not. Yeah. This was the completely different device. I'm sorry for confusion. We have to create a new symbol, but maybe KiCad, because KiCad is pretty good, can have a standard symbol. As you can see, here is TPS7A39, which is pretty same part number or symbol name. Data sheet, yes, it is our symbol. So I closed the window of the symbol editor, but anyway, TPS 7A39, here you are. I'm copying the symbol into my own library. Why? Because if you use the KiCad standard libraries, that's perfect. That's completely recommended after the proper check as well. Especially we need to check the pin numbers and the pin functions and order codes and anything, add the part numbers, add suppliers. So yeah, check everything, but at least the rough symbol saves us a lot of time. But I recommend to copy the symbol into your library. Why? Because when the next version of KiCad is released, it can happen, and it happened. It has happened in the past a few times, at least to me, because sometimes some of my libraries were missing, or some of my footprints were missing. So since then, I always copy both standard KiCad symbol and standard KiCad footprint into my library, because in your file folder, in your library, your symbols and folders and footprints are protected. So anyway, TPS A7A39. So let's check the pin numbers. For instance, here, input positive is number 1, enable number 2, positive. Yeah, that is something frankly, I hate, that the symbol copies the footprint. But as I can see, they use the same symbol in the datasheet as well, and to me it works pretty well. So yeah, this time I was wrong. The footprint pinout is suitable even for symbols. Okay, let's get back to the port checking. Ground is number 4 and invisible is 11, I think. We will see in the table, but yeah, there are 2 ground connection points. Thermal pad, as they say, connect the thermal pad to a large area ground plane. Perfect, we will do. 5 is negative input, 6 is negative output, feedback negative is 7, buffer output is passive, no output, buffer reference output is 8, with positive feedback is 9, and positive output is 10. That's good. What I want to change is the function of the ground, and we are fine. Let's check the, just for the sake of, I don't know. I always set the thickness of the shape of the rectangle of the symbol 0.25. Yeah, I just want to keep things on the same dimensions. Fine. So attributes. This is standard Texas PV-SON. Yes, they say 10 pin, 3 times 3. We have to check it because there can be a mistake, and this can cause dumb and unwanted mistakes. Okay, let's check this footprint from the KiCad. Come with me. Where are you? Can't switch the. Okay. Why you don't want to talk with me? Tell me. This is this is the footprint the standard KiCad symbol uses. What is this? Aha, they even that's not very common. They even place the ground polygon on the bottom side of the footprint. It means that it requires explicitly the ground plane polygon on the bottom. I always recommend to check the diameter of the drills. Sometimes there is 0.2, which is outside of the standard manufacturing profile of your PCB manufacturer, and it would cost you extra money. So 0.3 is perfect. And what the datasheets say, they asked for or requested for 4 vias. We have 5 of them, I think. Now I again lost the footprint editor. Okay, and yeah, same. It looks pretty same. Yes. The pad sizes are 0.24 times 0.6, 0.24. Yeah, they use a combined, slightly thicker and slightly larger, but that's okay. That's okay. These packages, at least for like small company, small lab, home, DIY manufacturing, needs slightly larger pads, because when you print solder paste, if you use stencil printing, sometimes you print a little more paste on the pads, and it's always beneficial to have larger pads when the unnecessary amount of solder paste can go away from the package instead of keeping below the package or making like thin balls near the pads. So larger pads for this small bottom terminated packages are always welcome. So this footprint looks good. What about the 3D model? Yes, there is. So I can freely copy the footprint into my library and check the 3D model as well. Again, step, I want the step, I don't want any other format. What concerns me is the cartridge, which is quite large. I will make the cartridge smaller and use the rectangle instead of 4 lines. Nice. I think we are ready to edit the properties of the symbol. My library is called like this. Yes, this is our footprint. Just for the sake of, I think it's the same link, but I will delete and copy the one I'm looking at in my browser. So yes, 𝗲𝘁𝗶, yes, 3 times 3, okay. Negative LDO, I'm making the string smaller, shorter, let's say shorter. Okay, V out, and V in. LDO, dual 100 milliamp. So it means that I can, okay, something like this. Manufacturer's order code. Let's check again the distributor side. The SCT is slightly more expensive, so we have to check the ordering info at the end of the, or near the end of the data sheet. So DCT is slightly more expensive. Why? It's packaging. Here is ordering. DSCT is slightly more expensive because I don't know why. It looks the same to me. Let's check the distributors page as well again. DSCT is €1 almost more expensive than the CR, CT or CR, CTCR, CTCR. CR is large tape and reel, and CT is small tape and reel. Okay, I don't have anything against large tape and reel. Okay, so we are good to use this manufacturer's order code. Taken from Mauser and JLCPCB. Look at your muscles. The price is perfect. Okay. And keywords: LDO, dual, negative, positive, something like this. Fine. Okay. The symbol is ready. I'm checking the comments. We are 48 minutes in the show, and I need to make a short service. Pause if you like what I am doing and you feel like beginner in KiCad. I highly recommend this online course I made for very well KiCad for beginners. You will create a power supply board like this. You will learn how to create symbols, footprints, schematic capture, 3D models, import graphics, manufacturing export, PCB layout, everything you need to start, like the KiCad Essentials. KiCad for beginners is for you. Now, give me a minute. I am back. Yeah, as I said, in a minute. Yeah, I'm back. Thank you for your patience. No, I didn't manufacture the traffic light yet. It's too soon. I didn't even send it to manufacturing. Things at the end of the year are a little bit tough. I have to work on other projects. But thank you for asking. It will be designed and manufactured in January probably. So we have the symbol for the LDO. What else? The op amp 𝗬𝗂𝗏. So I am too slow today. I have to be faster. 𝗬𝗂𝗏. No. So let's check the data sheet. I can close this. I can close this page. Okay, rail to rail, low noise, op amp JFET input. Single, yes. What they use? SOC? SOIC? Yes, SOIC. What is the best available package? SOIC? Yes, SOIC. This one. Okay, I expect standard, yes, standard pinout. 4 and 7 power supply, 1, 2, 3, and 6. Is it standard? I'm not sure now. I don't know. AD82? No idea. AD82. This is pretty standard. Where are you, boy? I'm confused today. This is dual. Yeah, we can copy this one and edit it. 𝗬𝗂𝗏. Let's check the data sheet here. Symbol editor here. So yeah, that's not standard. I saw correctly. Negative input is one. I was wrong. Negative input is 2. Positive input is 3. Output is 6. Negative source voltage is 4. Yeah, I'm wrong again. I'm looking at the original package, which was SOT235. So that is a different package with a different pinout anyway. I'm confused today. 7 is positive supply voltage, and now there are few not connect inputs or ports, better said. Like here, number 2, number 5 and number 8. Okay, now, yeah, the table view. 1 and C2 negative input, 3 positive input, 4 V minus, 5 and C6 output, 7 V plus, 8 and C. Correct. Now attributes. Yeah, you can see not SOT23 but SOC SC75, which is smaller but the same pinout usually. So it's 8. But I have to check the data sheet for the, yes, that's VSOP. Wait, what's the package? It's not SOIC, it's VSOP. Okay, VSSOP. But there is SOIC as well. But the most available package is VSSOP, yes. I will use the VSSOP. I'm thinking why they use the bigger package, maybe because of the availability or higher capacitance between inputs, because the input ports are further from each other. I don't know. I don't want to oversimplify the design. SOC is here, quite well available as well for the same price. I will use the same one. We are hunting picofarads. So yeah, every parasitic capacitance is not needed, definitely. I think the catalog parameters are the same, but the package is twice as big. Okay, so C. And the SOIC is without, yes. Without the EPAD, and the size is standard 4389 times 49. Yes, that's the standard package. The data sheet is here. This is something like op-amp, single rail to rail, low noise, JFET. So it's 8. Manufacturer's part number. Three on stock. Okay. What the other ones? 3000 of the SOT. Never mind. Op-amp JFET dual R2R or rail to rail. Good. Check again. Looks good. Fine. What else? The buff 802. So we can close this, and we have to open the Mauser line. this is our device. They say VQFN. There are no package details here, but it is VQFN, okay, which is this. What they use, something like this. Okay, let's try the KiCad, but 602. There is a standard package. We don't want to use it. Okay, new symbol. New symbol inside of the op amp. Where is op amp? 802. And we have to we want symbol editor here, and we want come on, here you are. So I don't know pin numbers again, but anyway, I will follow the same workflow. I will add the pin numbers later. So input bias is input. No, I will set it as passive, like here. Visible. Okay. Input, another input or input. Okay, that can be like here in aux. Okay, slightly lower, and our bias will be passive and slightly lower as well. Yes, I'll do it this way. On the top, VS plus, which is power output, power input, I'm sorry, power input. Somewhere here. VSO plus. I don't have a clue. What does it mean? VSO plus 12. VSO plus, which is like power stage, power input. Positive output supply connection for the output stage. Okay, so it uses different power inputs for both like low signal part and the output stage. Is it possible? Input stage, output stage. Now, what can be the difference? Input stage 14 is the difference between VS plus and VS minus, the same as VSO. The input voltage is almost the same swing of VS plus minus. VS supply voltage. Okay, so it means it looks like the voltage level should be the same for both VS and VSO, but they use a special port, like to lower the impedance or to avoid some parasitic effects, because this op-amp is pretty buff. This is buff. This buff op-amp is buff. Okay. Yeah, on the exact side will be power input as well. In fact, the negative power supply port is power output, but yes, output will be here. And now we have plenty of other pads. Okay, the CLH will be placed here, along with its non-connected thing. The same as CLL, which is a visible input. As well as on the top edge, the NC invisible port. Now these four, respectively 3, plus the EPAD. Yeah, I will modify slightly the shape. I want to place the setup ports on the left edge. Don't ask me why, I just want to. See. Okay, the shape. I'm not sure. No, I am sure. This is not how typical op-amp symbol looks like, but I like it. In bias 3, in, which is in, number 2, in aux 4, R bias 7, aux bias 6, EPAD 15, no 17, NC number 1, 9, VS plus 1, VS minus 8, VSO plus 12, VSO minus 10, CLH 15, CLL 14, NC number 2, 13, NC number 3, 16, output 11. Okay. When sorted by numbers, let's use this table, not this table, not. VS plus, yes. Input, yes. Input bias, yes. Input aux, yes. VS minus, no. Aha! There are 2 VS minus and 2 VS minus and only 1 VS plus. Yes, VS plus is 1 and VS minus are 2. Okay. Okay, 5 VS minus for input, and now I have to locate the VS minus here. It will be set as passive because it will share the location of the VS and invisible. Okay, again. So number 5 VS minus, number 6 aux bias, number 7 R bias, number 8 VS minus, number 9 VNC, 10 VSO minus, 11 output, 12 VSO plus, 13 not connect, 14 CLL, 15 CLH, 16 NC, and EPET finally 17. Okay, symbol checker says we are good to go. Think like this. Now the attributes. Buff 802, footprint 16 pin VQFN. I don't know. 3 times 3 they say. What is the size of the package? 3 times 3. Okay, so we QFN 16 exposed pad 3 times 3. What is this? Okay. No, we have only 1 exposed pad. But we want thermal vias like this. Okay, it looks like I have to check it in the footprint editor because it's too expectedly it will be there, then it will be that footprint, but where are you here? But we have to check. So exposed pad 168, yes, that's correct. The pad size is 0.6024. Okay, that's slightly bigger, but as I said before, it's only okay. 0.3 is the via size, and yes, I like it. Okay, this is the one. The 3D model looks correct. Okay, so this is our package. Datasheet is here. Description. Op amp JFET low noise, high speed, 45 to 625. How to create the plus minus? No. No. Anyway. UCC VQ EQ FN16 3 times 3 millimeter. Manufacturer's order code. This one. Mauser. Okay, so we are 1 hour and 17 minutes into the show, and what I can do yet today is to put only 3261, the symbols, the new symbols into the pane. There is TPS 7A39. This is the power section, and there is OPA140. There is BAF802, and many things we didn't even touch today. We have to deal with the connector, this one. We have to deal with the RF output connector here. We have to deal with the trimmer, but I think that's the easiest thing. We have to deal with some components. I think the entry section will be 0402. The other ones will be 0603. LED, no problem. Okay. My proposal is to conclude the session today because nobody wants to watch so long streams, and most importantly, I have another job today. So yeah, I think we have pretty good prepared for another day, another week. Another week we will create the schematic, we will capture the schematic, the entire one, and start the PCB layout, component layout. What I am going to do yet is some task list for today. So tasks for next week. We have to focus on tip, spring-loaded thing. We need to focus on power entry connector or way. We have to focus on SMA or MMCX RF connector. We have to take care or focus on yes, probably here ground pin or connection, and yeah, that can be what we want. So next week we will process with higher priority our tasks and finish the schematic As you can see, there is nothing special. This will be like in a few minutes. Only these components have a special values, but I think it will be fast. And here, yeah, it will take some time, but not so much. Thank you for being here today. The session wasn't filled with a exciting design job. It was a boring, slow preparation work for our following design job, but it's something that we need to do. Nobody will do for us, for us, and I think we are pretty good with the symbols. We checked everything, double checked everything, pin numbers are okay, ordering information, order codes, yeah, pretty good symbols, something that we want, and footprints as well. So thank you my friends, and see you next week. It means December 18, part 2 of the active probe thing, and yeah, that's a wrap. So thank you, and have a nice rest of the day, week, whatever you are doing. Bye bye.